Okay, welcome to this interesting little problem concerning a square that's been placed inside a 3, 4, 5 triangle. And we've got to work out x, the side length of the square. Okay, now I'm just going to put the main measurements in that we're given, which are that the base would be the 4, so this is 4 units across. Okay, this would be the 3, and the hypotenuse of this large triangle would be 5. Okay, and we've called the side lengths of the square x, and we actually need to notice that there are some similar triangles here. For example, if I mark this angle here, that's the smallest angle in the main triangle. Okay, I can see that that angle appears again over here in this smaller copy of the triangle here. Okay, and I can also see that this one is similar as well, because you can work that out from geometry of what you've got in front of you. So those three angles I've marked are all the same, and I can also then mark the larger angles. So this one up here, which is shared by both this little triangle here and the big one, that angle there is the middle sized angle. This is the largest angle, the 90 degrees. Okay, and that angle there is the same as this one here, and that one there is the same as this one here as well. Okay, so we have 4 triangles, the large one and 3 small ones, all similar. Okay, but some of them sort of flipped over. Right, so using that information we can make some comparisons between 2 of those triangles. Now I'll show you how we can do that. All right, this is now in a different color. So we've got here that if this is x, that corresponds to the 5. Okay, so that's the hypotenuse. So the short side here is 3/5 of x, and the base is 4/5 of x. Okay, because the hypotenuse then would be 5/5 of x, which is of course just x. So that's this little triangle here taken care of. Now if we go to a different one, let's use this one over here. Okay, now I've got to be careful to orientate it correctly, but let's suppose then that's our right angle, which it is of course. X is now representing the 3. Okay, so the short side, that's the short side, so the middle side is going to be 4/3 of x. Okay, because this is like 3/3 of x, this is going to be 4/3 of x. Okay, and the hypotenuse of this triangle, which is the one opposite the right angle, is going to be 5/3 of x. Okay, now there's lots of things we could do at this point to work out the actual size of x, because that's what we need to find out. But what I can do, the easiest thing here, okay, is to just use the measurements on the base, because I can see that 5/3 of x plus 4/5 of x must equal 4. So I'm going to use that to work out x. So 5/3 of x plus 4/5 of x equals 4. Okay, now I'm just going to put that into a common denominator. So I've got 15ths, so I will have that 25/15 of x plus I will have 12/15 of x, and that will give me 4, which of course is 60/15. So I have a common denominator throughout, so therefore I can see that 25x plus 12x equals 60. Okay, so 25x plus 12x equals 60, and therefore 37x equals 60. Okay, and so the exact value of x is 60/37. Okay, 60/37. Okay, which is obviously somewhere between 1 and 2. It doesn't really matter what it is as a decimal, but just to give you an idea, you can see that if that total length across there is 5, if this is somewhere between 1 and 2, it looks like it's about just over 1.5. That does seem to fit with what we see here. Okay, so that's one way of finding x from this diagram. Okay, so using algebra and comparing sides from 2 of the triangles given, okay, and using that to form an equation to solve for x. There you go. I should have said at the beginning of the video that you should have a go at the problem yourself first. I hope you did that. Take care.